Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Okay, I know you might be getting a little tired of this. I'm not Amy, but you guys have seen me before. It's Pryia. I'm here again. It is Math Wednesdays with the Learning Liaisons. So, let's go ahead and jump right in. I've got some questions for you, and I'm actually really excited about what I have. All right, let's start off. Question 1. Two siblings are selling lemonade to raise at least $320 for a new treehouse. If materials needed to run a lemonade stand costs $15, about how many glasses of lemonade will they need to sell if each glass is sold for $6? So if we have to figure out what we need, we know that we have two siblings, but the two siblings doesn't seem to be important in this case. So let's keep going through. They're selling lemonade to raise at least $320. So that seems pretty important. And they're getting a new treehouse. That's not important information. About how many glasses, it cost them $15 to start this stuff up. So out of pocket, $15 were spent. And they want to know about how many glasses of lemonade will they need to sell if each glass is about $6. Okay, so there's a couple different ways to attack this, but let's start off with the quick information that we know. We need about $320, and we can't forget that it also costs us money out of pocket in order to start this stuff up. So we have to add those costs together, because if not, we would be $15 short. So let's start with our $320. This is about what we're looking for. Remember, at least $320. And let's add the cost of everything that it's taking us out of pocket to start this lemonade stand. So we're going to add the $15 for the cost, And what we're looking at is we need $335. Okay, well, if each glass cost us $6, we sold them for $6 is what I meant. We just need to figure out how many $6 we need. So the best way to do that is to go ahead and do a division. So 6 goes into 335 how many times? So let's do some long division. Your test may or may not have a calculator. So let's do it by hand. I did forget to mention, which I said I was going to be better at, it is an algebra problem. It's middle or high school level, okay? So back to the math. 6 does not go into 3, so we go to 33. 6 goes into 33 without going over 5 times. We subtract 30. We get the 3, bring down the 5. 6 goes into 35 how many times without going over? It is 5 times again. Subtract 30 and you're left with 5. Well, we have a remainder of 5, but let's see where that takes us. So we put a decimal at the top, make that 50. 6 goes into 58 times to get 48. So that's all I need. I know now that the 55 gets rounded up. No matter how you look at that, we had to sell an extra glass. So 55 glasses. Well, I'm looking at my answer choices, and we have a lot of different answers going on here, and 5 doesn't seem to be on there. So let's figure out where we need to be. Well, if we sold 53 glasses, that wouldn't give them enough money. 44 glasses as well. They're looking for a number that's closest to what we just got. So 210 is definitely out of the question, and the only one left in this case would be 60 glasses. Yes, we had 56 glasses that we needed to sell, but we needed to round to whatever nearest number we had as an answer choice. All right? Questions? Moving on. I'm going to remember this time to tell you that number 2, question 2, is an algebra problem, and it can be found in middle school and or high school math, right? And this question comes to us that says, which one of these relationships does not represent a function? Key word here is the does not part, right? Does not represent a function. So we have to know what a function is in order to figure out what's even going on or understand the problem. So in simple terms, a function is defined by each input has a single output. In other words, I can say for every x, there is one y value. Okay, so in another way to say this, if I had to keep going to help you out, I would say there can only be one x when numbers are written out. So when we're looking at this, and let's say we had the graphs, the charts, right? If we had these charts and this was x and this was y, let's just give us some numbers. I don't know why I wrote them backwards. Couldn't tell you why. I cannot have 1 go to 4 and to 3. That would not be a function. That means there is 2 outputs for that one input, which goes against everything we just talked about. So when we're looking at our answer choices, we're looking at something that does not work. Well, we need one x value throughout. It cannot repeat itself. So looking at A, we have 2, -4, and 7. Well, that checks out to be a function. So that is not the answer we're looking for. For B, we have 0, -1, and 2. Well, that also checks out to be a function, so that is not what we're looking for. For C, we have -1, -5, and -9. Again, that is a function. That is not what we're looking for. Here is where we get the kicker. We have 2, -5, and 2. 2 repeats itself, so 2 is making this not a function. So our answer that we should choose here is D. Winner, winner, chicken dinner. I miss saying. All right, here we go. Number 3. Number 3 is also an algebra problem, middle and or high school level, so you can see this in both, right? So we have a question, it just said if, then that, and they gave us some numbers. So we have to figure out what we're doing with this. Well, first off, I want to start with the if part, and I'm going to take that and solve for x because I really don't know what else to do with this. The answer choices aren't really giving me much. So let's start there. 8x plus 5 is equal to 21. Okay, seems easy enough. Well, let's do some math. Well, the 5 needs to be moved because remember, we don't like our x. That's why we're not with them anymore. And we need to move everybody else away from them. So let's go ahead and move the 5 over to the other side. So the opposite operation of addition would be subtraction. Move the 5, and what are we left with? We have 8x is equal to 16. Okay, well, that doesn't seem so bad. I have an 8x and a 16 left. What is the next step that we need to do? Well, the 8 and the x are mushed together, which means multiplication. So the opposite operation would be to divide, or other words, divorce out. So we're leaving. Remember, we don't like our x. We want to get away. So 8 over 8 is 1, and we don't need to keep repeating that. 1x is the same as just saying x is equal to, and 16 over 8 is going to give us 2. Well, that's got to be my answer, right? I found the value of x, and x is what I'm looking for. Is 2 my answer? No, it is not our answer. So 2 is not what we're looking for, but it takes us one step closer to solving the problem. Remember we talked about that extra part, the then part? Well, we did the if, now we need to then. Let's go ahead and plug in what we now know for x into the problem. So the original problem is x minus 1 is equal to, we don't know. So our answer choices must be the we don't know. So let's go ahead and solve. Well, remember, we know that x is now 2. 2 minus 1 is equal to 1. That is our answer. That is winner, winner, chicken dinner. All right. It's one of those problems where if you didn't see the second half, you would definitely get this wrong. So we want to make sure that when we're looking through problems, even though we know how to do the first half very quickly and very easily, it's nothing too much. We want to make sure that we're paying attention and that we're answering all of the question and not part of the question. Because if you noticed, 2 was an answer choice. We get so excited when we're on our exams because we're timed that once we see a number that we've gotten, that's it, done deal. Go ahead, zoom in on it, click on it, move to the next question. But that's not always the case. We want to make sure that we're going through and asking ourselves, did I solve for everything? All right, here we go. Number 4. This is something far from algebra. Well, not really that far, but it's not as easy as the last problem. So this one's definitely going to take some skills and some memory if you've done it a long time ago and you haven't done it in a while. This is one of those things that you're going to need some space. So this is a matrix problem, and it's coming from advanced or linear algebra, and it's definitely at a high school or college level. And I say college level because some high school courses towards the senior year, you can go into college level. So this could be seen in both, either high school or college, right? So this is something that's a little bit more than just that regular algebra. This is definitely asking for a little bit more from us. It's asking us for the product of the following matrices. So these are the matrices. Sometimes you have to figure out if the matrix is even going to work. So you need to know a couple little tricks just to start you off. The first matrix is a 3 by 2 matrix, and we're multiplying it by a 2 by 3 matrix. Why is this important and why do we need to know this? If the two inner numbers do not match, you cannot multiply the matrices. I mean it. Yep, that's it. It's as simple as that. If the two inner numbers do not match, you can't multiply the matrices. And then the cool thing about this is the outer numbers are going to tell us how large the next matrix is going to be. So our answer matrix should be a 3 by 3. So we're looking at all the answer choices, and 4 is a 3 by 3. I meant A is a 3 by 3, B is a 3 by 3, C is a 3 by 3, and D is a 3 by 3. So it doesn't help us eliminate any answer choices in this case, but it may in the future. So little things that help you now may help you later. Okay, so now we actually have to do the math and I'm gonna need some space. So what I'm gonna do is I'm gonna take us down to the next slide. I'm gonna rewrite the entire problem, the two matrices at the top. So we have them, 3, 6, 5, 1, 2, 4. We're multiplying that by 9, 8, 2, 7, 1, 4. All right, let me fix that 8 because I don't know what's going on over there. Okay, let's try that one more time. Boom. All right. Okay. The name of the game is the first matrix. You go from left to right, and the second matrix, you go top to bottom. Okay, what do I mean by that? I mean that as you're multiplying, you will notice that we will start to multiply numbers from the first matrix with the second matrix. We're going to add these numbers together once we're finding products. And once we start doing this, this will make sense, I promise. Okay? So let's start with the first row. Yes, row goes across. So we're starting with 3 times 9. And we're adding that to 1 times 8. Did you see how I went across and I went down? So I used my 3 and my 1, and I used my 9 and my 8. Okay, now I need to keep going. I have 3 numbers to put on the first row, and I only have 1 number so far. So now we keep going. We're going to use the 3 and the 1 again, but now we're going to do the 2 and the 7. So 3 times 2 plus 1 times 7. And if we keep going, we're going to get 3 times 1 plus 1 times 4. Okay, we're going to get numbers after, so let's just keep putting them in. We're going to have 6 times 9 plus 2 times 8. 6 times 2 plus 2 times 7. and 6 times 1 plus 2 times 4. All right, last row, 5 times 9 plus 4 times 8. I like to put the numbers in the parentheses, so when I go back right before I start multiplying and adding, those parentheses numbers have to match in each column, okay? And then the numbers outside the parentheses have to match for each row. If you have numbers that don't do that, then something went wrong and you might want to just start again, all right? We're almost there. 5 times 2 plus 4 times 7, and then 5 times 1 plus 4 times 4. Okay, now it's just simple multiplication and addition. We'll have 27 plus 8, which is going to give us 50. Just kidding, it's not 50 anything. It's 35. Going across, so straight, we'll have 6 plus 7, which is going to give us 13. And then we'll have 3 plus 4, which is going to give us 7. Okay, let's keep going. 6 times 9 is 54 plus 16, which is going to give us 70. Then we have 12 plus 14, which is going to give us 26, and 6 plus 8, which is giving us a lovely number of 14. Okay, almost done. Last row. 5 times 9 is 40, plus 4 times 8 is 32, giving us a lovely 72. Then we have 10 plus 28, giving us 38. And then we have 5 plus 16, 21. Okay, so this is our answer. Okay, when we go back to our answer choices, we need to see this one. 35, 13, 7, and then let's just remember 70 and 72. And let's go see if we can find one of those answer choices. Well, off the bat, the only one I see that has a 35 in it is over here. So our answer, the product of the following two matrices, is going to be A. Right? Doesn't seem so bad. It's a little bit lengthy. This one over here is action identity matrix. Sometimes I know you guys see things and you're like, oh, I've seen that before, but I can't remember what it is. That's an identity matrix, just in case you were wondering. Okay, so let's dial it back a little bit. We went full force, full speed. Let's go to some geometry. And this geometry can be found in middle and or high school. All right, let's read the question. A circle has a center of 4, -2, and passes through the point -2, -3. So what are they asking us to do? Find the equation of the circle. Well, in order to do little things like that, you need to know information. So what is the equation supposed to look like? It's supposed to look a little like this. Oopsies. X minus h all squared plus y minus k all squared is equal to r squared. So how is that even helping us? Where is this h and this k coming from? And how are we supposed to find information that we just have 2 points for? So let's start with, where's the h and the k coming from? Well, the h and the k is actually coming from the center of the circle. The center of the circle, that point can be rewritten as h comma k. Okay, well, if this can be written as h comma k, then all we're going to do is take those numbers and plug them in, and let's see where it gets us. X minus 4 all squared plus y minus negative 2 all squared is equal to r squared. Okay, not too bad. We have a couple more numbers in our play, but we're still missing some pretty important information. And before we move forward, let's take care of this double negative. So let's go ahead and rewrite this entire equation to as many combined components as possible. So x minus 4 squared plus y plus 2 squared equals r squared. All right, well, we still need to figure out what's going on with that guy, right? Well, how are we figuring this out? What do we know? We know that the center of the circle is there, and somewhere out in no man's land is this other point. I am not drawing it accurately, so please do not behead me for this. We have another point, and that point is negative 2, negative 3, right? This is just a quick sketch. Doesn't really go on the graph at this point. I'm just putting points and stuff down so we have a visual representation of what's going on. And you can do this as well. It doesn't have to be perfect. Sometimes just seeing it helps you understand it. Well, if I know that the center of the circle to some point on the outside of the circle, what is that called? Well, it sounds like something we're missing, and it's called the radius. So when you go from the center of a circle to the outer part, which is the exterior of the circle, not pass through the exterior of the circle, but to the outside, we're going to have a radius. If you were wondering what about the diameter is from one end to the other end. That's not what we're dealing with. We're only dealing with from the middle of the circle to the outside of the circle. Okay, well, that doesn't really help us because now we just know what it looks like, but it does help us. Now we need to use the distance formula to figure out how long, what the distance is from the middle point to the outside of the circle. Well, just in case you haven't used the distance formula anytime soon, I will give that to you. We have x2 minus x1 squared plus, I don't know why I paused, y2 minus y1 all squared, and that is all under the square root. So you have to take the square root of all of this. Well, pick which one you want to be y2 and which one you want to be y1, and which one you want x2 and x1 to be, and just plug them in and get an answer. So I'm going to go ahead and do 4 minus 2 squared plus negative 2 minus 3 squared. Okay? Well, my two negatives are going to make positives, right? And I'm just going to add what's in my parentheses and then square them. So if I add what's in my parentheses, I'll get 6 squared plus 1 squared. Okay, so my answer to that would be the square root of 37. But remember, that's my radius. Radius is just r. But that gives us a little bit of an issue because we need r squared. Well, it's quick, it's simple, I promise. Ready? r is equal to the square root of 37. But I want r squared. So I square both sides. It's a rule. It's a thing. It's illegal. It is legal. It's not illegal. You could totally do this. Ready? R squared is equal to what? Just 37. I promise, it's a thing. It works. So now all we're going to do is put 37 where r squared is, and we're going to have our final answer. So our answer is going to read, let's pick a different color. R squared is going to read, the final equation is going to read x minus 4 squared plus y plus 2 squared is equal to 37. That is the answer we're looking for. Based on this, we only have two answers that have 37 as the equal, the sum, the end. And we're looking for a -4 and a +2, which happens to be B. Winner, winner, chicken dinner. Okay? It's one of those things that you need to know a lot of background information for. But once you know, it's not that difficult. If you get stuck, ask yourself, well, what are things that I can do? If you noticed from this part here, we could have gone into the answer choices and found an answer choice. There are no two answer choices that have -4 and +2. So in this case, we could have just kind of cheated and gone forward. But if there was another answer choice, we would have had a 50-50 chance, right? So little things like if you don't know how to move forward, try to find an easier way to eliminate some of those answers that we're not looking for and try to get yourself back on a better path to getting to the correct answer. So food for thought. Ready? Number 6. All right, I said I had some treats for you tonight. Tonight, we're doing some trigonometry. I know. What's that? It's a thing I like. So the thing about this trigonometry is it's asking us a very simple question, but we need to know some of our own information, just like the last problem. So they're saying if sine of A is equal to 3/4, then the value of tan A, tangent A, is what? So these are our answers for tangent A. Well, I need to know a few little things. Like, there is a trick to help us through this. There is this really cool thing I learned when I was in, I believe, high school. And, they told me that I would never forget, and they're right. It's this whole SOHCAHTOA thing. Totally worth it. What does it mean? All right. It means that sine is equal to the opposite over the hypotenuse, that cosine is equal to adjacent over hypotenuse, and it means that tangent is equal to the opposite over adjacent. Okay, this is some pretty good stuff. This is really going to help us through this. So what do we have? We have the sine, and we're looking for tangent. So we have this information, and we need to turn it into that information. Okay, so if we rewrite it, we're just going to put sine is equal to 3/4. Well, based off of this, we know the opposite and the hypotenuse. So if I was to actually draw a triangle, I would have my hypotenuse here. My opposite would be over here. Oops, that would be 3. This would be my opposite, and this would be my adjacent. Well, let's plug in what we know. We know that 3 goes here, 4 goes here. We don't know what this thing is. So we have to figure that out. Well, this is only going to work if it's a right triangle. So I know that in order to solve for the side of any right triangle, any side of a right triangle, I'm going to use Pythagorean's theorem. So I'm going to start there and see if that helps me get to where I need to be. So I'm going to say a squared plus b squared is equal to c squared. I'm going to plug my stuff in. So I'm going to have 3 squared plus x squared is equal to 4 squared. Okay, I know that c is always my hypotenuse, so I'm going to put that in over on c. It does not matter how you put in the opposite and the adjacent for a and b. Let's keep working through. So I have 3 squared, which is 9, plus x squared, which I can't really solve for yet, is equal to 4 times 4, which is 16. All right, I need x squared by itself, almost there. So when I subtract 9 onto both sides, I get that x squared is equal to 7. Okay, that's great, but remember, this is just x, it's not x squared. So I'll have to take the square root of both sides to get x by itself. And now I have x is equal to the square root of 7. And that's my adjacent. So if tangent is the opposite over the adjacent, and we now know that the adjacent is the square root of 7, from before we know that the opposite was 3, what we're looking for is D. That's it. 3 over the square root of 7. Tangent A is 3 over the square root of 7. That's it. Winner, winner. Chicken dinner. Number 7. So it's another trigonometry problem. And this may be one of those problems where you're looking at me like, what do you think? What are you doing? How are we going to do this? I don't know the last time I saw this stuff. I promise it's not that bad. You just need to know your trig identities. And if you know your trig identity, this is easy peasy. All right, so to start off, I'm going to give you some trig identities. I could totally fit them on this page. So let's go ahead and do some trig identities. I'm going to keep all my trig identities in green at the top of the page, and then we'll do the work at the bottom together. So some things you need to know is tangent theta, which it doesn't have to be theta, it can be any angle or number or anything at that point, is equal to sine theta over cosine theta. Okay, and then we also have secant theta is equal to 1 over cosine theta. We have cotangent theta is equal to 1 over tangent theta. And we have cosecant theta, which is equal to 1 over sine theta. And then my favorite one, which I always remember, is sine squared theta plus cosine theta is equal to 1. Okay, so that's it. That's all we know. So now we have to figure out what we can use to change this and make it simplified or changed or help us by using these identities. Well, first off, I see secant, and I know secant is here. I have a tangent, and I have tangent here. And I have this lovely 1 minus sine, which I'm sure is going to come from over here. So let's see what we have and what we can do with it. So I'm going to rewrite the problem. Secant A plus tangent A is multiplied by 1 minus sine of A. Now I'm going to plug in what I know, okay? So my secant was 1 over cosine. It's going to be of A. And I'm going to add that to my tangent, which is sine of A over cosine of A. And then, my sine squared theta plus cosine squared theta equals 1. I can change that and have that equal to what I need it to be. So I'll have cosine squared theta is actually equal to 1 minus sine squared theta. All I'm doing is subtracting the sine onto the other side, both sides, and that's what I'm left with. So I'm going to rewrite over here cosine squared A. Okay, well, we're a little bit closer to where we need to be. I can rewrite what's going on in here together. So let's go ahead and rewrite it together. Maybe help us out a little bit. I'll have everything over cosine A, and I'll have 1 plus sine A, and that's all being multiplied by cosine squared A. Okay, well, that didn't help as much as I thought it would, but you know what we still can do? We can go ahead and multiply the cosine in, cosine squared A, and then in one step, I'm going to separate the fractions. I'm going to keep them separated fractions. So essentially, I'm going back to the step I just, combined from, but I promise it's going to help us. So we'll have cosine squared A all over cosine A plus sine A cosine squared A all over cosine A. Okay, well, that stuff helped us a little bit. You could have rewritten it without separating it, which at that point it's kind of just user discretion, well, mathematician discretion. I know that I have over here a cosine at the top, and that's all I'm going to be left with because I have 2 cosines at the top and 1 cosine at the bottom, and a cosine over a cosine will give us 1, so I'll get 1 plus, 1 multiplied by that cosine that's left. So I have cosine A. I now have to figure out what's going on the other side. Kind of the same rule applies, but now we have a sine attached to it. So we're going to keep the sine with it, but we're going to reduce the cosine in the numerator. And we're going to have sine A cosine A. That is the answer we are looking for. And that happens to be C. All right, so it's one of those things where you're using these identities to help you get through the problem. You can manipulate it in different ways to help you get through it however you see best. That helps maybe like make it a little bit easier or anything like that, right? So I liked keeping them separate instead of combining them. You could have combined them. You just had to make sure that when you were reducing, the cosine not only went to the first number, but it also went to the second number, which is your second term. All right, I wanted to do 2 trig identities. It's just like that sometimes. So here's another trigonometry problem. And here, instead of giving you all of the ones that I gave you before, I'm just going to tell you this information. So cosecant theta is equal to 1 over sine theta. And we're going to use that throughout this entire problem. that is what we're doing. So I'm going to rewrite it and then plug in what I know. Well, I'm just going to plug in what I know from here. All right, so what do we have? We have 1 over sine theta for a cosecant, but we have cosecant squared. So cool thing here is we'll have 1 over sine squared x minus 1 all over 1 over sine squared x. I promise it works just like that. Okay, if you notice, we have a fraction within a fraction. And when you're dividing by a fraction, we have the lovely keep, change, flip policy, or trick. We're going to keep the first fraction, change the sign to multiplication, and flip the second fraction. So it's going to look a little like this. 1 over sine squared x multiplied by sine squared x all over 1. We kept this one, we multiplied and flipped this one. And because it's minus, we're going to do it one more time. We're going to keep the numerator, which is 1 over 1, because 1 by itself can be written over a 1. Anything by itself can be written over a 1 to give you a fraction. And we're going to multiply by the reciprocal, which is sine squared x over 1. Okay, we're almost there. When we do this, we have sine squared x is going to become 1. So we're just going to have a 1 here, minus, because 1 over 1, 1, 1, all that's 1. So it just becomes 1. We're going to have that minus sine squared x. Our both denominators are 1, so we just have whatever's left in the numerator. And that's the answer we're looking for. But what's wrong with the answer? One, it's not an answer choice. So there's got to be something that we missed that we maybe didn't remember. Well, remember earlier I told you that was like one of the ones that I always remembered? So we have to change this one last time, okay? So we're going to change it to cosine squared x. Because if we solved for cosine squared x, we would have 1 minus sine squared theta, or x, is equal to cosine squared theta. So this is the actual answer that we should be looking for. And it's an answer choice. They don't seem so bad after you deal with them a little bit. But trig identities is one of those things that it can be a little tricky. If you're not using the correct identity, you're not going to get to where you need to be. All right, I put a calculus problem on here. I know. Who wants to do calculus this late at night? I do. That's why I'm here. All right, so let's do the calculus problem together. It is asking us to solve for the limit. So this whole thing, we're going to need the whole thing. So when we have a number that it's telling us to go towards, so the limit as x approaches 0, I'm actually going to take that 0 and plug it into all the x's and see if we can get an answer. So the shortcut way to all of this would be 0 squared minus 16 all over 0 squared plus 2 times 0 minus 24. Okay, well, 0 squared is 0, 0 squared is 0, 2 times 0 is 0. So the only thing we're left with is negative 16 and negative 24. All we have to do is simplify and figure out what's going on with that fraction, and that's it. We have an answer. Off we know it's not going to be no solution and it's not going to be 0. We're going to have a fraction, right? So let's figure out what our fraction is going to be. Well, negative 16 over negative 24, a negative over a negative is going to give us a positive. So we know off the bat that it's going to be a positive number, which happens to be only one answer choice, but let's do the math together. I know that 8 goes into both the numerator and the denominator, and we'll get 2/3. All right, our answer here is 2/3. Limits may look tricky and scary, but sometimes they're not as bad as you make them seem. If there was another number like 2 or 3 or 5 or whatever the number may have been, we could have still used this trick. Because x is approaching a specific number, you take that number and you plug it in to your function, whatever your limit is telling you to, whatever you have, and you can plug out an answer. Sometimes it's as simple as that. There are other rules, terms, and conditions that may apply. In this case, it's just that simple. I got to number 10. Okay, so number 10, here we go. It is an algebra problem. It is something more that you'll find high school, right? It's not necessarily a middle school problem. It's a little bit more high school, and it's high school because of the domain, right? You talk a little bit about it in middle school. Might fall into a middle school category, but a little bit more than just that. So we have to find the domain of the function. Well, I know when I was growing up, domain and range really stumped me all the time. So I always did this anytime I had to do a domain and range problem. I wrote them at the top of the page, and I reminded myself that domain is my x's, my x values, my x-axis. And range is going to be my y's, my y values, my y-axis, right? So when I'm looking at this, they're asking me about my x values. Well, if I take my function and I graph it, I'll have a better idea of what's going on. I can then look at my x values and actually be able to figure out how my x's are being represented. It just so happened that in this case, they kind of gave you a little help because all of your answers are x's. So we had to have been looking at the x. We don't necessarily have to graph this, but I'm going to tell you that graphing it's definitely going to be one of the easiest things you can do in this case. All right, so let's go ahead and graph our function. Okay, well, I know that -4 is my y-intercept. And I also know that 2 is my slope. Okay, so this is in y-intercept form, which is y equals mx plus b. So all we're doing is plotting it out and seeing what we get. So I'm going to start with my y-intercept at -4. 1, 2, 3, 4. Okay, so here's my -4. Now I'm going to do what my slope says. Remember, slope is rise over run. And right now my slope is 2 over 1. So what I'm going to do is go up 2 and to the right 1 and up 2 and to the right 1. And then to give myself a little bit more to go off of, I'm going to go down 2 and to the left. Down 2 and to the left 1, and we're going to pretend and go down 2 more and to the left 1. Okay, so here is where my line will be drawn. And if we're looking at the x values, we're thinking, okay, what values are being, approached, what values are going to be within the function, what will make this true, however you want to look at it. But if this line continues on infinitely, and this line continues on infinitely, then what will happen? I will have values from negative infinity all the way to infinity that's included in my domain. Well, if that's the case, then the answer is going to be all real numbers. All numbers are included from negative infinity to infinity. And that's because my line goes all the way out. So the other answer choices are telling us that we're stopping somewhere and x is only greater than or less than whatever that value is, which means that only a part of my line will continue. The other part does not exist. But in this case, when I graph it, I have a line that continues on at the top and at the bottom. We're going all the way out, right? Our function is complete function. It goes all the way out. So it has to be all real numbers. All right. That's it. I actually made it to 10. I know, pretty surprising. But before I leave, I wanted to say thank you for coming. Thank you for being here and thank you for watching. And if you need some one-to-one extra help, we do have online tutoring. It's under the tab that says online tutoring. We try to make it easy for you. And it can be found from our website, right? www.thelearningliaisons.com. And, you know, we have other things than just one-to-one tutoring. We have comprehensive video boot camps for math, and don't forget your discount code SINK35, SINK 35. All right. Thank you all for being here, and you have a great evening.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.